All right. Hello, everybody. Welcome back to Comp 2450. I hope that you are all doing good today. Gosh, I don't know about you, but it was really nice to wake up and see the sunshine this morning. Yeah, that was really nice. I notice again that OBS is telling me that like we're dropping frames like crazy here, and it's just cutting out completely. So if you're on the stream right now, apologies. I don't know. I can't control the Wi-Fi in this room, but I am recording this lecture again. So if you're watching this, if you are in this room right now and you're watching this after the fact and it's a mess, please let me know and I'll just try to upload the video that I've recorded instead of the live stream. All right. So I hope that you're all doing good today. What I want to start taking a look at today is I want to keep taking a look at some of the stuff that we were doing last week. So reminder of last week, what we were doing was coming up with test data and then eventually building up this automated test harness to basically take the tedium and error-prone manual testing out of us. So we're writing software effectively to pretend to be our parents, to try to put data into our software, to put data into the methods that they might realistically be putting in, and then evaluating the behavior of the methods that we've got there. I want to finish that up today, and the thing I want to finish up with today is I want us to be able to do something called measuring the coverage of a test suite. So we're going to build up this test suite. We're going to write all these methods that are evaluating behavior. I want to be able to take measurements about how good or bad the test suite that we have is. And then I want to move on to starting to take a look at persistence. So, so far in this course, as soon as we hit the stop button, everything's gone. We got to start all over again. And the goal here is really to be able to make it so that even as we are pressing the stop button, when I press play, some data will have been persisted somewhere so that I can start back up again and there will be state. I'll have state that I get back from this. To start this, I don't really want to focus on the mechanics of doing data persistence yet, but instead I want to focus on making changes to the structure in our application. And so I want to start thinking about this new or additional principle from Solid called the dependency inversion principle. And I want to start thinking about that in terms of the layers of responsibility that we've got. I'd like to add a new layer of responsibility to the code that we've got. And then I'd like to start thinking about how we can coordinate the construction of these different layers of responsibility such that we're sticking to this dependency inversion principle. So far in this course, we're writing these tests. We're writing this test data out. We are writing methods that are taking the test data that we've got and we're putting it in. And this is great, but the problem with this is it's kind of hard for us to know if the tests that we've got are actually good. I'll give you some sense of like the idea of writing these happy path tests, these general cases, and these edge case tests. The ones that are valid but look weird, the empty string, things that are getting really close to the edge of being valid and invalid in our domain model. These are a good way to make sure that we have good tests, but it's not necessarily an objective way to make a measurement of how good the tests are that we've got. I want to think about this new idea that's called coverage. Test coverage here is a measurement that we can take of how many lines of code, how many classes, how much of our code base was executed during the test suite. So we're going to have this test harness that's filled with these methods that are all calling other methods in our code base. Test coverage is going to be a measurement of when I take the entirety of this test suite, which lines of code in my actual code base, in my domain model, in my logic layer, which of those were actually executed by this test. And the goal here is I want to make sure that I have some high amount of test coverage. I'd like to try and cover all of the lines of code. I want to make sure that I've tested both the exceptional state and then the happy path state. I want to make sure that I've done both of these different branches in the code that I've got. I'm going to take a look at this with IntelliJ right now. If you want to follow along with me and you've already got a test harness, I invite you to do this with your own. But I've also merged the testing stuff that we've done last week into the main branch of this sample. So if you want to pull that and kind of follow along, please do so. So I've got our test harness here. This is the one that just has all of the methods that are put right into the main method. Remember from last week, this idea of a test harness is just, this is what runs our code. It keeps track of the successes, it keeps track of the failures, and it tells us a little bit about the things that happened while this was running. When we ran this the first time, we hit this play button and we let it run. And what we got as output was this nice, bubble text here that prints out what we're doing. We get these green messages to say that each of these tests have succeeded. If they failed successfully, we actually caught the exception that we were expecting to get when we did this. I'm going to run this in a slightly different way now. I'm going to right-click on my main. I'm going to go down here to More Debug Run, and I'm going to run this with coverage. So this option here is kind of hidden in the menu that we have for running this thing, but the one I want to choose here is with coverage. With coverage is going to get IntelliJ to run it. It's still going to run this code, but as it's running it, it's going to keep track of which lines of code have actually been executed as part of running each of the tests that we have here. So I'm going to hit this button. And what's going to happen is the tests will run. So if I expand this, we can still see that we got this normal test output, that the tests have run, they have succeeded. But what also shows up here is a coverage report. This coverage report is showing us the packages that we have and the classes that we have in our main package of code here in that source main Java folder. And it's showing us how much of each of these things have been executed by running the test suite that we've got here. So in my domain model, this is a Pokemon test. It is running 100% of the classes that are contained within this file. Remember, there's two classes in there. There's one for Pokemon and there's one for Pokemon Builder. So we've created instances of both of those classes as part of the execution of this test suite. It's running about 66% of the methods that are defined in those classes. So we're not running all of the methods in those classes, but we're running a lot of them. And we've got about 68% line coverage. So there's 54 total lines in this Pokemon file that can be executed. And of those 54 total lines, 37 of them have actually been executed by one of these tests. These numbers are valuable at a high level, but they don't really tell us a lot about what lines of code were actually executed here. And so what you will also find when you run this with coverage, when you run these tests with coverage, is if I now go to the Pokemon class here, on the very left side of the display, we can see these green colors. I'm going to scroll up here. We can see more green colors here. This is the constructor for the Pokemon class. I'll scroll down, down, down. We can see things like yellow, and we can see things like red here. The red says this line of code never ran as part of the tests that you just ran in the test suite that you had. So this kind of makes sense for me from my perspective that the precondition checking to see if all of the conditions that are applied to a Pokemon are not null. It makes sense to me that this hasn't run because we haven't actually applied any conditions to our Pokemon yet. This collection that we've got of conditions is empty. We have added moves to our Pokemon, and so it makes sense to me that this would be covered. Testing, to be clear, is not about our preconditions. It's not about our class invariants, and so this part isn't super valuable. But as I scroll down here, what I can see is, for example, I have not tested the attack method. I haven't tested this at all as part of the test suite that I wrote. And so this is an indicator to me that I should probably write that test and make sure that I'm able to observe the side effects that I'm expecting to see as a result of having this Pokemon attack another one with one of the moves that it has. So I'm going to go back to my slides here. When we're doing measurements of testing, there's a few different things that we really want to think about. One is that all the tests you write should pass. So if you're expecting to see an exception based on some input, that test should pass. If you get an exception but you're not expecting to see it, that test has failed, and we want to fix the code so that we don't see that thing happening. Yeah. I'm not actually sure. If I go back up here and I see yellow, these lines are yellow, and I'm not sure why they are yellow because they have been executed. So you're right to say that this is what it would look like when you have version control attached to this with Git, but in this case, these are being shown explicitly because of the test coverage that we've just asked it to do. I gotta be honest with you, I don't know what the yellow means. I'm much more interested in the red and the green than the yellow anyway, because I know for sure that red means this line was not executed, and green for sure means this line was executed. Yeah.
I think maybe the yellow is kind of like, if it hit that line of code with this condition, that will make it actually execute the code, kind of like a Boolean. It's a Boolean. If it's like an if statement, and then it evaluates the false, I think.
That could be. It's evaluating this to false. I don't think that's true, though, because if this evaluated to false, it would have failed our precondition. Yeah, yeah. Okay, so you're right, yeah. Wow, thank you for searching Google for me in class. Again, I don't really care that much about the yellow one. I really care a lot more about red and green here in terms of measuring how much test coverage that we've got. When we're measuring our tests, all of our tests should pass. When you submit code that has a test suite, all the tests should pass. This is something that we will always try to have when we're working with code here. One thing that's kind of an aside here is that as we're writing our tests, this is something that should reveal to us if the API that we've written is awkward to use. So what I mean by that is if you're writing a test and you're having to kind of bend over backwards in terms of setting up the structure that you need to be able to evaluate this test is really difficult. Writing this test can tell us if it's awkward to use and give us a hint that it might be something that we need to change. The one that I'm really concerned about in terms of testing, in addition to all tests should pass, is that we should have as much coverage as we possibly can. We want to make sure that we're going through and assessing as many branches and as many lines of code and verifying the behavior is expected. Verifying the behavior is what we're expecting it to be. There is a limit to this, though. There's diminishing returns at a certain point. And I'll let you read this article on your own if you want. I like this article a lot. It's called The Tragedy of 100% Code Coverage. And the short of the idea is that there are lots of methods that it really doesn't make a lot of sense to test, like pure accessors that don't do anything except for return a value. There's not really a lot of value in testing that. It's just an accessor. It doesn't do anything. It doesn't have side effects. It really doesn't have any kind of behavior. And so while 100% test coverage is something to strive for, there's diminishing returns here. There's not a lot of value in going all the way to that point. Yeah.
I'm sure you all covered this, but for all tests, they should include invalid paths as well, right?
For the tests that we've got, the invalid paths that we want to test are going to be within the context of our domain model. So yes, so like if we have a constraint in our domain model on the empty string for something, then we should have a test that evaluates that behavior. I want to see that I get this exception when I pass the empty string to this thing. But not null. I don't ever want to test for null. My parents can't type the word null in. I want my tests effectively to behave like what my parents are able to type in. Yeah. Any other questions? I don't know about all of you, but gosh, am I looking forward to a reading week break. Yes. Okay, so this is kind of the end of testing for us. When we are looking at phase 3, when we're looking at phase 3 and we're starting to assess the testing, we are going to be starting to take a look at the test coverage measurements here to get a sense at a high level of how much coverage you have for the test suites that you've written. That will be part of what we're doing for that. All right, let's switch gears here. Every time we start our app at this point, we're kind of starting from scratch. We enter a bunch of data to try and test something. We enter a bunch of data to try and simulate the behaviors that somebody's doing. We do a bunch of manual testing here, but every single time we have to start this thing back up again, we're really just starting from scratch. In some cases, hard coding can help us. And so I've tried to demonstrate this a little bit in one of the examples that I've given to you here, where we've got a main method, start battle main here, that really just hard codes some data so that I don't have to constantly re-enter this data every single time I start the application so I can get to the thing that I'm actually trying to evaluate. But that doesn't really help us in the context of saving something that my parents have actually typed into my program as they're using it. Hard coding helps us get to that point, but it really doesn't solve the problem that we have of I want to be able to save the state that I've got of this application while it's running. I want to be able to save the state of this application that we've got while it's running so that when I turn it off and bring it back up again, I can get that state back without having to go through the process of typing all that stuff in. In the context of a library, for example, I don't want to have to return check out a book and then return it all within the same session. I want to be able to check out a book, leave the library with that book, read the book, and then eventually come back and return this thing. So I want to be able to save the state of the application while it's running, and I want to be able to restore that state later. Just like with testing, I want to try and set some expectations for what we're going to do in this course and what we're not going to do in this course for persistence. In Comp 2450, we're going to use JSON. I will tell you a little bit more about what JSON is on Wednesday. The information that you need to know right now is that JSON, if you haven't heard of this before, it's a text format. It is a plain text format. That's all you really need to know about it right now. And we're not going to be writing JSON ourselves. I'm not going to be expecting you, again, if you've seen JSON, to have curly braces in your code to represent JSON stuff. We're not going to write JSON ourselves. We're going to use a library for this. We're going to be putting the state of our application into JSON objects, and we're going to be writing those out to files, and these are just plain text files. We're going to have really coarse-grained persistence. And what I mean by that is we're effectively going to save the state of the whole thing every time. If you've got 15 different kinds of classes, at a certain point, you're going to be saving 15 different kinds of classes when you do this persistence. We're not going to be doing any kind of fine-grained things. We're just going to save and load everything at the same time. We're going to use unique identifiers. So we'll spend a little bit of time thinking about what these unique identifiers might be in the context of the software that we've got. And finally, that's it for what we are going to do. What we are not going to do in this course, and again, I want to make sure that we're just setting expectations of what we're trying to accomplish here. We're not going to use SQL. If you've heard of SQL before as a way to do persistence, We're not doing that in this course. We will do this in Comp 2452. So when you join me in that class, that's where we're going to start talking about SQL. We're not doing SQL here in this course at all. We're also not going to use a server in 2452. We'll do it locally, but we're not using a server. We're not having some separate machine. We're not doing any kinds of connections or anything like that. In this course, we're not going to care about performance at all. I don't care if it takes 5 seconds to save everything. I don't care. I really do not care in the context of this course. That's not what's important to me in the context of this course. I don't care about optimizing the behavior of our code to be able to save and load individual objects from a file. I really just want to get the whole file and all the objects, and I want to save all the objects to the whole file. I don't care about finding anything in the file. I welcome you to do this independently if you want, but this is not something that we're going to be doing in this course. I don't care about that very much. If you know anything about databases, and if you don't, you're very welcome to just shut your brain off right now for the next 2 points here. We're not going to do referential integrity in this course. This is something that applies to when we actually use actual databases. So when we get to Comp 2452, in Comp 2450, we're not doing referential integrity. Everything is persisted or it's not persisted. Everything is loaded or it's not loaded. We're just doing everything all at once here. We're not going to discuss primary keys in this course. If you've done databases, you have some sense of what that means. We're not going to talk about primary keys. We're not going to talk about composite keys. We're not going to talk about secondary keys. We're not going to talk about indexes. We're not going to talk about any of the relational database stuff in this course. That's not in scope for this course. So we're doing JSON, we're saving things as plain text, we're doing things very coarse-grained, we're loading and saving everything all at once. We're going to have unique identifiers in that we must have unique identifiers at some point, but we're not going to be doing things like proper key stuff in Comp 2450. We're also not going to do any queries. There are JSON query languages. We're not doing queries. We're just loading everything into memory and saving everything all at once. OK, so setting expectations here. The first thing that I really want to start doing in terms of persistence is to start thinking about the layers of responsibility that we have. And I want to start thinking about how we can make changes to the layers of responsibility that we have to add this new thing that we're going to be thinking about. Yeah.
Yeah, so I just wonder if we want to save the state regardless of how the program ends. For example, if the condition gets triggered and throws an error, we save everything before that.
So this is a good question. The question is about saving the state of an application. In this specific context, it's in exceptional circumstances. So something has failed, we would otherwise be throwing an exception or catching an exception. What I'm going to say is that for this course, we're going to have specific points where we'd expect you to persist things. So it's not going to be saving the state when there's a crash. It's more like after this interaction is completed, we'd expect you to save the state of the application right here. And we'll define those for you. We'll tell you what those points of persistence are going to be, but it's not going to be saving it at arbitrary locations based on something has failed to meet the preconditions that we've set for design by contract, for example. Yeah. So far, the layers of responsibility that we've got are a UI layer and a logic layer. The UI layer has some responsibility for interacting with the person that's sitting in front of the keyboard. The logic layer has the responsibility of doing the application logic that we've got. Neither of these really have the responsibility to do persistence. And so what I would like to do is add a new layer to the diagram that we've got. And I want that layer to be called a persistence layer. So I'm going to pop over here to my tablet. This is a diagram that we've seen before, that we have amended before once we started adding our validation stuff to our domain model, so adding our builders. Let's quickly take a look through here to remind ourselves of what the structure of this is. We've got our human on the very far left side of this thing that's actually sitting there typing at a keyboard. they're providing input to our UI layer classes. These classes have the responsibility to collect that input, validate it to some extent, transform it into things like integers and the other primitive types that we have in Java, and then ultimately passing some information to our domain model objects themselves, where the domain model objects have these builders that are delegating the responsibility of construction and validation of those instances. Our domain model, our builders, pass these instances back to the UI layer. So this is all kind of happening in the UI layer and our domain model layer. The UI layer then passes those domain model instances to the logic layer. The logic layer here does whatever it needs to do for the logic. So it makes changes to that domain model object, or it makes changes to its own internal state. And then it will return back to this UI layer. It may be throwing exceptions, it may be returning something, it may just go back, it returns void, nothing comes as a result of this. The UI layer then has the responsibility of printing or displaying some domain model instances, whatever has changed or whatever state it's back in, and we send this back out in our text-based output. We print that out to the person that's looking at the software that we're using. In between the UI layer and the logic layer here, we've got this interface. This is an interface between these layers. And what I'm going to say about the interface between these layers is that these are the methods that are exposed by the logic layer. And the way that we're communicating across this interface is using our domain model objects. What I want to do now is add a new layer to this. And so I'm going to scroll over here to the side. The layer that I want to add here is going to be the layer that has the responsibility to do persistence. The layer that has responsibility to do persistence is going to be the one in the context of our course that has the responsibility of taking domain model objects and writing those out to a file on disk. In between the two layers that we've got here, and I'm going to pick a different color to represent this, we're going to have an interface. And in this case, I literally mean a public interface. What we're going to do in between our logic layer and our persistence layer is define in Java an interface, a public interface that defines the behaviors that this implementation will be able to do. So it's going to be a public interface, defines methods. Or behaviors. This is what this thing can do. As part of the logic layer's responsibility to make changes to itself or to make changes to the domain model instances that have been passed to it, our logic layer is going to have the responsibility of asking the persistence layer to save our objects. So again, we're going to say that this is happening after some flow has effectively completed. You click the submit button because you want to check out this book. Your logic layer, upon successful checkout of the book, should persist that information to this persistence layer. It should ask the persistence layer to do this for us. In our case, what we're going to have I'm going to write the word JSON on top of this, is to write domain model objects to disk or file. This operation that we're describing here, this is transforming domain model objects into strings. Our UI layer has this responsibility of transforming strings and other inputs into instances of our domain model. Our persistence layer has the opposite responsibility. It's going to take these instances of our domain model and transform those back into strings so that we can write them out to a file. This may have the responsibility of sending things back that have been modified, maybe. In the same way that the logic layer may be modifying these instances, maybe send these modified instances back, maybe raise an exception, maybe return nothing, but just send something back to say that, yes, thumbs up, I've persisted this thing. Yeah. That's a fair question. The question is ultimately, I thought the persistence layer shouldn't make any changes to the domain model objects. We're now, I personally am starting to think about different implementations of persistence layers. So the thing that I'm specifically thinking of, and again, this is outside the scope of this course. So just to be very clear about what I'm about to say is not in this course, it's going to be for later courses. When we think about things like primary keys, they are often incrementing values that are provided by the actual implementation of the database itself. Our domain model, our logic layer, they should not have any responsibility to come up with what those unique keys are supposed to be, but the persistence layer does have that responsibility as it interacts with that actual database software. The database software auto-generates the key itself, and it has to have that responsibility to make sure that duplicate keys don't start showing up in the database tables. And in that case, it would have to modify that instance to say, this is the ID that was populated as a result of saving this thing to that database table. Well, it's going to modify it in that it's going to set the ID field on this domain model instance. So you'll have this field that's a private thing. It will have a mutator to provide a value for it. And it might modify that value from being empty to now being some non-null value to represent that unique identifier in the database. Again, in the context of our course, we're not doing that. We're just going to assume that the objects that we have all have their own unique identifiers. And so that's why I'm writing maybe here. We're not really going to be making any changes to this stuff. But that's a fair question. So thank you for asking that. Yeah.
Like whenever, for example, we have a list of profiles and the UI asks to delete the profile, and in that case, we don't really ask the persistent layer to remove that profile or just to rewrite the entire thing.
Again, in our specific implementation of this, we will remove it from the collection that we've got and then just persist the whole collection, replace everything that was there already. So we're not going to do caring about loading or saving individual objects. We'll just remove things from the collections that we have in our own Java implementation and then save that entire collection to the disk. The side effect is the same. We're just approaching it in a slightly different way. Yeah. The other thing that our persistence layer is going to be responsible for is our logic layer and our UI layer may be asking for this data to come from the persistence layer. So when we start our application up, our UI layer may be asking for some setup stuff. Our logic layer may ask our persistence layer to load initial data. And our persistence layer, again, will have this responsibility of loading files, loading domain model objects. From files. And so this, again, is going to be, we're going to transform strings into domain model objects. Our persistence layer is going to have the responsibility of taking domain model objects and saving them to disk by transforming them into strings. It will also have the responsibility of reading the file's contents, getting the strings out, and transforming those back into domain model instances. It's doing it in a different way than our UI layer is, in that our UI layer is actually expecting somebody to be sitting there typing at a keyboard. In this case, we're going to be reading this from a file as opposed to typing stuff in on our keyboard. Okay, I will share this diagram with you up on the course webpage so that you have access to that. What I want to do now is switch back to our slides very briefly. And I want to ask you the question, what are these different layers of responsibility actually responsible for, given what we know about these different layers of responsibility so far? I'm going to hold this up for a couple seconds, then I'll switch over to Mentimeter. The questions that I'm asking, I'm looking for you to make 3 selections for each of them. So you get 3 choices. I want you to pick 3 different things for each of the things that we're looking at here. I'm going to pop over to Mentimeter. I'm going to hit the present button. I'm very sorry. Just pretend that you didn't see any of that stuff. Okay, yeah, just pretend you didn't see any of that stuff. I'll give you about 5 seconds to answer for this one. Okay. I'm going to show the correct answer here. And I'm delighted that we're focusing on these main responsibilities that our UI layer should have: getting inputs and producing outputs. I'm delighted that we're focusing on transforming this input into instances of our domain model. And I want to give a spiritual thumbs up to this one. Yeah, we're actually doing that right now. But I'm going to argue that that's not actually the responsibility of our UI layer. We're doing it right now kind of because we had to at the time when we were thinking about this stuff. But I'm going to argue that this is not the responsibility of this layer to make instances of other layers of responsibility. It's the logic layer responsible for. I'll hold this up for 5 more seconds, and then I'll show the correct answer. Okay. I'm delighted that we're picking this one thing, and I know that I've messed you all up because I let you pick 3 things. Yeah, I was unintentional, I'm sorry. I'm delighted that we're focusing, though, on this one, do application logic. I'm also really delighted to see that producing output and getting input have basically 0 selected. I am delighted by that. I'm very happy to see that we have these clear separation of responsibilities between the logic layer and the UI layer. The UI layer is I/O, the logic layer is just logic. I'm going to say that the logic layer does not have this responsibility. In the same way that the UI layer does not have the responsibility to save data to files. That's not the responsibility of this layer. I'm going to say that just like the UI layer should not have the responsibility for making instances of other layers of responsibility, I'm also going to say that the logic layer does not have any responsibility to make instances of other layers of responsibility. It should not be making new UI classes. It should not be making new instances of other classes that it depends upon. Here's the last question, and I see that some people already started answering here. This one, I'm going to say pick just one, pick just one. Picking just one gives it away immediately, and I'm delighted to see that we're all focusing here on saving data to files. The persistence layer doesn't have the responsibility of making other instances of layers of responsibility. It doesn't have that responsibility. I'm actually going to give a spiritual thumbs up to this. Not even spiritual. I'm just going to give a great big thumbs up to the person selecting this one, the two people selecting this one, because I literally just said it has that responsibility. So yes, please, yes, big thumbs up for that one. But the primary one is saving and loading data from files. Saving and loading data from files. I'm going to pop back to my slides here for a second. No layers of responsibility should have the responsibility of creating instances of their dependencies. The word dependency is not necessarily something I've used before in this course, so I'm going to tell you what I mean by that. Our UI layer class, excuse me, our UI layer class depends on the logic layer. It depends on instances of classes in the logic layer. All by itself, the UI layer class cannot do anything. It can get that input, but it can't ask nothing to do stuff. It has to have some dependency on some other class that has methods that does the stuff that it thinks that it should be able to do. I'm also going to say now that based on the diagram that we've got here, I'm going to switch back to that. The logic layer has a dependency on the persistence layer classes. The logic layer should not have the responsibility of making instances of these classes. It should not have that responsibility. Solid is a set of design principles that describe good practices for building object-oriented software, but I'm going to argue just in general, just good software will adhere to these principles. In Comp 2450, yeah. In Comp 2450, we've talked about the single responsibility principle. So far, domain model objects should have the responsibility of managing their own data and not really anything else. The UI layer class should have the responsibility of doing input and output, but not logic. The logic layer classes should have the responsibility of doing logic, but not input and output. Persistence should have the responsibility of just saving and loading stuff. That's all it should do. Open closed is something, and I'm going to look to you with a kind of quizzical face and ask the question, have you talked about this in Comp 2400 yet? So Comp 2400, maybe. You might see this in Comp 2400. I've heard John throwing me under the bus about stuff that we're supposed to be doing in Comp 2450, so I'm going to throw John under the bus, and I'm going to say John should be doing this open close principle. Maybe. You might see this when you're starting to think about things like inheritance and class hierarchies and how these different classes relate to each other in terms of how you can make extensions to a class. I know for sure that you've done Liskov because John has told me that you've done Liskov, and I'm assuming in Dan's class you've also done Liskov, but you might be slightly behind. I'm not really sure what the state of that course is, but I know 100% for sure that you're talking about Barbara Liskov and you're talking about her substitution principle. The interface segregation principle is something that you might see in Comp 3350, maybe. This is a principle that requires a scale of problem that we cannot approach at the 2000 level. This is something that requires the scale of problem that we've got to get to like big projects in 3350 and 4350. So software engineering 1 and 2 at the 3,000 and 4,000 level courses. We're going to talk about D, the dependency inversion principle, in this course right now. The dependency inversion principle is a principle that effectively says each class, and when I'm using the word class here, what I'm primarily thinking about are the layers of responsibility that we have, classes in the layers of responsibility. Each class should depend only on what the class can do. It should only depend on what is exposed by the interface of that class. Our interfaces are a way for us to specify behavior. This class can save. Things that implement this interface can save stuff. They can load stuff. They can do things without saying how they're going to accomplish those things. Each class in a layer of responsibility that has a dependency should depend only on what that class can do on interface, not how it works, not what it actually does underneath. What I really want to accomplish here, despite the diagram that we've got here that has the word JSON, is I want my logic layer to be able to save instances of my domain model, full stop. It doesn't need to know that this is a JSON implementation. All it needs to know is that if I pass an instance of this domain model object to my save method, things that implement this public interface will do something to persist it. That's all I need to know about in my logic layer. I don't need to know that it's JSON. I don't need to know that it's SQL. I don't even want to know that it's either of those things. Classes that implement this interface will do the work that I want them to do. That's what I want to be able to depend upon here. We're going to do this using a strategy that's called dependency injection. So the dependency inversion principle is saying you should depend on interfaces. Dependency injection is we're going to force you to depend on interfaces by making an interface, an actual public interface for the persistence layer that we're working with. And we're going to change instances of our logic layer class to accept that interface type as part of their constructor. Our logic layer classes have a dependency on a persistence layer implementation. We will pass that implementation into the constructor. We're going to change our main class to coordinate construction of all these objects. So it's going to have the responsibility of making instances of all the dependencies and passing those instances to the different layers as they need those things. That's where we're going to start next class. And so at this point, what you should be able to do is measure the test coverage of a test suite using an IDE. And at this point, you should at least start to be able to apply the dependency inversion principle to an existing code base. So verbally, we're going to make changes to our constructors and the dependencies, and we're going to make some other class have the responsibility of coordinating all of this stuff for us. That's it for today. I hope you all have a great rest of your day, and I will see you all on Wednesday. Bye, everyone.